Hello and welcome to the paper solution of engineering drawing December 2013. Myself Arpan Pandit. I am from Atmiya college and we will see the further portion of this paper solution of December 2013. Let's have a look at the next problem, please. The next problem is about projections of a line. Now when we are talking about projections of a line, first of all we will see that what are the basic fundamentals which we need to clarify before proceeding to the projections of a line. So it is very necessary that our fundamentals for the projection of a point is very much clear before proceeding to the projection of a line. So first of all, there are some facts about these projections of a point that must be clarified. So what are the facts? First of all, let's have a look at what are the facts about this. Facts about projections of points. Now, when few things must be very much clear in the mind, when it says that above HP, point is above HP, then it comes above XY line. When it says that below HP, then it comes below XY line. When it says that in front of VP, then it is below XY line. If it is behind VP, then it is above XY line. On HP means on XY line. On VP, which means that on XY line. Seventh, on HP and on VP, which also means that on XY line. So these are the facts about projections of a point. If says that a point is above HP, then it should be represented above XY line. If says that point is below HP, then it should be mentioned below XY line. If it is says that in front of VP, then it should be below XY line. Behind VP, then it should be above XY line. If anything says that on HP or VP, it should be lie on the XY line itself. Now when we are talking about the HP component, it would be denoted by A dash or B dash or with the dash. Or when we are talking about the VP vertical plane component, it will be simple alphabet A, B, C, X, Y, Z. So these are the facts about this projections of a point. Now let's have some idea that how these projections of a point can be plotted. Now first of all, let's draw a reference XY line. A reference XY line. This is a reference XY line. This is a reference XY line. Now we are having 3-4 kind of a problem. One says that point A is 10 mm above XY, 10 mm above HP and 15 mm in front of VP. 10 mm above HP, which means that it would be above XY line, and 10 mm in front of VP, which means that it would be 10 mm below XY line. HP component is denoted by dash. VP component would be denoted by simple thing like this. If says that a point B is 20 mm above HP and 20 mm behind VP. 20 mm above HP, which means that above XY line, 20 mm behind VP, which means that this point will also be above XY line, means that B and B dash would be at the same point. In one example, it has been said that point C is on HP, which means that on XY line, and 50 mm in front of VP, which means that 50 mm below XY line, on HP, which means that dash component would be over here and VP component is down there. Last problem would be on HP and on VP, or both points are located on HP and VP, which means that both are on the XY line. So this is how a projections of a point covers. Now we will see how our problem can be solved. Now let's have a look at this question. What has been the given data? The given data are as following. The plan and elevation of a line PQ 100 mm long measures 80 mm and 70 mm respectively. So first of all, we are having some sort of given data that need to be right first of all. Data given. Data given. True length is given 100 mm. Plan is given 80 mm. Elevation is given 70 mm. Location of point P is given. Location of point P is given 10 mm above HP and 15 mm in front of VP. So what we need to find out? We need to find out theta and phi. We need to find out theta and phi. Now we are having some sort of given data. With this given data, we will plot the projections of a line. As a reference, we are going to draw a XY reference line, horizontal XY reference line. A horizontal XY reference line. Let's first of all plot the point number P. Point P is 10 mm above HP, which means that 10 mm above XY line, and 15 mm in front of VP, which means that 15 mm below XY line. HP component denoted by dash, VP component denoted by simple alphabet. Now when we are drawing the projections of a line, we'll draw parallel line from both P dash and P to XY line. Like this, we can draw this. Now we have been given some data. We are having some sort of data over here. This distance is 10 mm and this distance is 15 mm. Now here is some data. First of all, we are having data of a plan. A plan length is given as 80 mm. So from point P we will mark a horizontal distance of 80 mm like this. We have marked horizontal, naming it as small q, naming it as a small q, taking P as center, Q as radius, marking an arc like this, marking an arc like this. Same way, marking point on 70 mm, marking an point at 70 mm as a elevation. Naming it as a small q dash. We have plotted arc like this, naming it as a q dash. Now we are having a true length of 100 mm, true length of 100 mm. So I will take radius of 100 mm. I will be having radius of 100 mm. And marking it from this Q point like this, and same for from this Q dash point over here like this. We have got our true length over here on both the side. We have got a true length on both the side. This is TL is equal to 100 mm. This is also true length is equal to 100 mm. Now this point would be said as capital Q dash. This point would be said as capital Q. From this Q dash and Q, we have drawn a parallel line to the XY line. On both the side. Both the side like this. We have drawn a parallel line on both the side. Now when we measure this angle, it's called theta, angle with HP, this angle phi is equal to angle with VP. Plan length is given as 70 mm. This is 70 mm. And this length is given as 80 mm. We need to measure this theta and phi. Theta comes around 66 degrees. We need to write in the designated place theta is equal to 66 degrees, and this phi angle with VP is called 45 degrees. 45 degrees. So this is how a projections of a line can be traced if elevation and plan has been given. These are our true given data. True length is given as 100 mm, plan is given as 80 mm, elevation is given as 70 mm. Location of point P, 10 mm above HP, 15 mm in front of VP. First of all, we have traced this P point, then we have put down, or both are plan and elevation, taken the arc accordingly and measure this intersecting arc as 100 mm and given the arc, and this is how we have traced the projections of a line. We will see our next problem. The next problem is about projections of a plane. Now in this it has been said that a rectangular plate ABCD of 40 into 60 has shorter side on HP and it is inclined to 60 degree to the VP. Draw its projection if it is inclined 45 degree to the VP. Now in this, a 40 by 60 rectangular plate is there. Its angle with VP is 60 mm given and its angle with HP is given as 45 degrees. Now the projections of a plane problem is very conventional thing, that it concluded always in 3 parts. Step 1, initial position. Step 2, the implementation of HP angle to the rectangular plate, and step 3, collaboration of HP and VP angles. Now let's draw and let's start how we can draw projections of a plane. First of all, draw a XY line. First of all, draw a horizontal XY line. A horizontal XY line. Like this. Now